Hello everyone, today I'll do a user requested tutorial on how to rig these sci-fi landing gears on this improvised spaceship using Morph Targets in Unreal Engine 5. This spaceship has these 4 landing gears that are animated based on the height that you're trying to land. They adapt. For example, you can see that if you're landing from the same position, they're extending all the way, but if you try to land a little bit lower, they just extend the needed amount to hit the ground. And I'll now move over some obstacles, and now you can see that each of these landing gears is adapting to the terrain below. One of my viewers contacted me and said that he saw the rig for my rear suspension of the bike and said that he wants to recreate this effect in his spaceship landing gear. I found this free pack on the Kitbash 3D website. You can go on this Minerva link, and then down here you can see that you can get this kit for free. It includes a lot of sci-fi meshes here, and this landing gear is just one of them. Near the end here, this is the model that I'm using. It's exactly the same landing gear. So export this model with right click, asset actions and export, and save it as FBX. I already did that, and I'll now show you how to do this in Maya, but you can do it in every other 3D software. I'll put in the description the name of all commands in Blender, so you can easily find help if you need to know how to do anything of the shown workflow here in Blender, because the viewer that wrote me for this tutorial said that he's using Blender. That's why I'm trying to include all the information that he needs. Let's move to Maya and open a new scene. Import the model that you exported from Unreal. Just drag it here. It comes with 4 meshes for the 4 LOD levels and 1 additional mesh for the collision box. You don't need that for now. I'll just delete it. I'll work with the highest level mesh. I'll delete everything else. I'll unparent this and I'll delete this. I have this landing gear imported now and just single mesh to work with. I'll move the mesh that way that it sits in the XY plane. You'll need a little bit of planning. Let me show you the final result for this mesh in Unreal to explain a little bit better what we're going to do. If we go to the skeleton, you see that we have 2 morph targets imported here, one for the top suspension and one for the bottom suspension, and they're being controlled by our animation blueprint according to the rotation of our bones to animate. Let me just explain what you will need to do. I've done this extremely detailed graphic, as you can see. This is our landing gear. This represents the top part. This is the bottom part. So this yellow part is this top rectangle here, and the gray part is the bottom one. And the other 2 items here are supposed to be the suspension arms for the top and the bottom. You'll need for the rig some bones for rotating the actual landing gear parts, and they will control the movement of the suspension. First, mark these points on your model where you want everything to be connected and where your rotations are pivoting. And we will create locators for this. In Blender they're called empty. And then after you have this part, we'll use that to rig our model in Maya. We'll save 3 meshes that are the base state that you want your object to be when it's in the resting state, when nothing is rotated and moved. Then you want just the top suspension arm contracted, everything else in the model will be the same, and then one where the bottom part is contracted and everything else is the same. And you use those 2 items to add as a blend shape or a morph target in Unreal Engine or shape key in Blender to this base mesh. And after that, when you rig it and then import to Unreal, you can have your animation working. This needed because these suspension parts are not moving according to the movement of our bones, and otherwise you need to have some physics simulation in Unreal with constraints how these parts are going to move, and you're wasting calculations and additional CPU cycles just to run this kind of simulations. And actually you don't need that. You can pre-bake your animation in Morph Targets and use those only based on the movement of your skeleton arms. Okay, let's start doing that in Maya. First, we'll start with marking our spots with locators or empties in Blender in order for our rigging later to be easier. Okay, go back to Maya. And now I'll split this model into separate ones. That way it will be easier for me. All these parts will move together, so I'll combine them to a one mesh. Same goes for these parts. Combine them to one mesh too. These parts as well. This is our top arm of the landing gear. Combine everything here as well. And this our bottom arm. It's just a single piece. Let me see if something... Oh, we have these parts that needs to be combined too. Combine them as well. What's this? This part is part of the top. And this is the bottom. I have separated the model into these parts. These bottom suspension parts are the same as the top ones. So I'll just delete the bottom ones and I'll use the top ones instead. First, let's mark the places that I showed you on the diagram here. Let's create a locator. Snap it here to the middle where the rotation axis for this should be. I'll change the color of the locator so it's a little bit easier to work with. I'll duplicate this locator. I'll move it here to the middle of this part. I'll snap it to the center. I'll snap this one to the center too. I'll make a third locator It will be the center here. Snap to the center again. I'll make the fourth one. It will be in the middle of this part here. Snap to this. And for the last two, I'll need the two places that they connect in the middle. As you can see, this one and this one. For the first one, I have it here. Let's show the rotation axis. Duplicate this locator, snap it here. Snap again to the middle. And the last one will be duplicated and will be here, the top part of this plate here that is holding the two suspension arms. These are all our locators done. Now let's snap our pivot points for each object to the proper locator. This one is the last one. So every object is now rotating properly based on the pivot point that you placed on the respective locator. And for the bottom suspension, we'll just duplicate those later. In order for our rig to work best and to be easier with our constraints later, we need to put these parts on the 0 coordinates on our scene and orient them to face one of the axes directly. So they're not like now diagonally, they're just facing one of the axes. The easiest one for me will be the y-axis pointing up. So let's place this object in the middle of our coordinate system at 0, 0 point, and then rotate it to face exactly on the y-axis. I think this is fine. When you have it dialed in, freeze the transformations so everything is zeroed in order for the translation and rotation, and all the scale values are set at 1. Do the same now for the top part of the suspension. Snap to the middle of our coordinate system and then rotate it exactly to face the y-axis. This is fine for this part as well. So freeze the transformations for this part too. And now you have both of the suspension parts exactly in the middle with all the values frozen to 0, 0. This is the easiest way that we are going to create our constraints later. So make sure that for these parts of the suspensions, they're facing directly to the y-axis and that they have 0 coordinates for translate and rotate. Now let's continue with the creation of our skeleton. In Blender this will be called Armature. Let's show these parts to explain what we're going to do. We're going to create these parts here. So these arms of our skeleton will control the movement of our top and bottom part of the landing gear. So we'll have one root bone where our coordinate system starts. Then one bone will start here for the top part of our landing gear. One bone for the bottom one that will start here and end on the tip of our bottom our skeleton will look like this. I'll hide this and I'll create it. Start from the center of the coordinate system, create joint, snap to the center of the coordinate system, then snap to the top pivot point for the top part of the landing gear, then snap to the pivot point of the bottom part, and then snap to the end of the tip of your landing gear. And this is our skeleton done. Let's rename our joints. In order to move properly our locators with these bones, we need to parent them properly, each onto the corresponding bone. So this last locator here for the tip of our bottom landing gear will be parented under the tip joint. This one will be parented under the bottom. All these three will be parented onto the top bone because they're moving with the top bone. And this one will be parented just on the root bone. So if we move our whole skeleton, it moves with the model. So now what you need to do for the suspension, I'll duplicate both of these objects so we can use one for the top and one for the bottom. So duplicate them and hide the extra ones for now. And we'll start with the top one. Select the locator that will have our top part of the suspension fixed. Then select the top part for your suspension and create a point constraint. You don't want to maintain the offset that we have currently. We want to move the part to the location of our locator. So uncheck the maintain offset and make sure that your offset is set to 0 and that you're constraining all of the axes to the point of the locator. So when you add this constraint for your object, it will move to the place where you have your selected locator. Then select the locator that you want to point at with your top part of the suspensions. In this case will be this one. You can see in our diagram the top one is connected to the top suspension here. So select the top one, select this and use an aim constraint. It's called track to constraint in Blender. Again, make sure you don't have offset, everything is set to 0, maintain offset is unselected, and you constrain all the axes for the rotation. So when you click add or apply for this constraint, it will orient your part of your suspensions to look at this locator that you selected. So do the same now for the bottom part. Select this locator, select this part, and add a point constraint. It will move to this place. Then select this locator where you want to aim, then add aim constraint. And now you'll notice that when we move our suspension, our landing gear skeleton, that our suspension is working properly. Do the same now with the other parts for the bottom one. Unhide them. Let's start with the top ones. Add a point constraint here. Okay, so add an aim constraint to this one. Then select this one, add a point constraint to place it here, and add an aim constraint to look at this bottom locator. And now you'll see that when we move our suspension, everything moves the way it should. This is the setup that you need for animating these parts. Now what you need is to create these three objects that we have here, the base one, the one with the top suspension contracted, and the one with the bottom suspension contracted. To have two morph target values, you need to have two models where only the part that you want to be animated with this morph target is changed from the base model to the one that you're adding as a morph target. So for our top contracted morph target, we'll just make our top suspension contract. And for the bottom one, we'll make our bottom suspension contract. In order to have these three models, we need this top part 2 times extended, we need the bottom part 2 times extended, and we need 1 time the top one contracted and 1 time the bottom one contracted. And we'll just need 3 times the same shape for the landing gear. To do this, you just move your suspension to the point that you want your morph target to end. For this model, if I unhide these parts and if I parent them to the bones here to be easier to visualize, so I'll parent this to the top bone and I'll parent this to the bottom bone. So now if I animate my skeleton, everything is working as expected. And for this model from the Minerva Kitbash 3D kit, I noticed that this top and bottom bones can be rotated maximum to 30 degrees. And this is where you start to have your geometry colliding with each other. So this will be our max value, 30 degrees for the collapsed parts and 0 for our extended part. Let's start with the top one. Just rotate the top part 30 degrees, so this is fully contracted. Duplicate these top parts and we'll delete these constraints. And now we have the top part done. Let's combine it. Select the top and then the bottom. The order that you select your parts when combining is important, because for the morph target to work properly, you need to have all your vertex information the same for each object. So make sure that you always select them in the same way. So select the top, select the bottom, then combine them, then delete the history, and I'll hide it for now. Let's return to the 0. Let's make the extended part for the top. So duplicate those, delete the constraints, select the top one, select the bottom, combine them, delete the history, and hide them. Now let's do the bottom ones. Let's first create the contracted part, select the bottom bone, contract to 30 degrees, duplicate those, delete all of the constraints, combine them, delete the history and hide them. Now let's do the extended bottom part, duplicate, delete all of the constraints, combine, delete the history and hide it. We'll need those parts as well, the top one and the bottom one. Duplicate them, unparent from our skeleton, and we'll combine them as a one object. Let's hide it. So this rig that we used to create everything, let's save it by hiding it, and if we need it later, we'll just have it in the scene. But for now, let's use our duplicated parts As I said, you need the extended parts twice, so duplicate the top extended suspension once and duplicate the bottom once. Duplicate this part 3 times, and now you can see that we have 3 times this landing gear part, 2 times our top extended, 2 times our bottom extended, and 1 time for the each one contracted. Let's start combining all the parts. Let's start with the basic shape. Start with the top suspension, bottom suspension, and then the landing gear itself. Combine them into one mesh. Delete the history and hide it. This will be our base mesh. Let's call it landing gear base. Then start with the next one, where we have the top contracted, the bottom extended, and then the landing gear. As I said, the order that you select everything is important. So start with the top, then the bottom, and then the landing gear. Combine them, delete the history, and call this top compressed. Let's hide it. And then start with the top one, bottom one, and then the landing gear, the same way as you did before for the last one. Combine them and call it bottom compressed. Now select the 2 parts where you have your suspension compressed, then select the one that you have as a base mesh and add a blend shape deformer. In Blender this will be called shape key. And now we don't actually need those. I'll not delete them for now, but just hide them. And you see that in our base mesh we have this blend shape added with controls for our bottom compressed and top compressed blend shapes. We'll use those in Unreal as a morph target in our rigging. So let them be at 0, and we'll now rig them to the skeleton that we created earlier. I'll keep this one so we have the rig that we did before with the constraints, and I'll just duplicate it. I'll delete all the locators and the meshes that we parented before from the new one. We'll just have the bones, unhide them. Okay, this is our skeleton, and this is the object that we want to rig. Select the root of our skeleton, select the object, and then bind this object to the skeleton. Now you have to paint your weights, which bone will control what vertices on your model, because now you can see that it's just like a jelly all around. Let's start with all the bottom parts of our landing gear. This should be mapped to our bottom bone. I'll put the values as 1. Everything else, let's hide the bones. Everything else should be connected to the top bone except this top suspension, which will connect to the root bone. Deselect this top suspension. And both the bottom suspension and the top arm of the suspension will be moved with our top bone. So add 1 for all those vertices. And now for our top suspension. We'll have everything here parented to the root bone. All our parts of the top suspension, and we'll do them fully controlled by the root bone. That's because we don't want this part to move when we move our top suspension or our bottom suspension. We want it just to compress with our morph target, and the bottom suspension will actually move with our top arm and will compress based on our morph target. Now if I rotate the top bone, you'll see that everything is moving with the top bone except for this top part, but it will be controlled by the blend shape. So if I rotate this to 30 and then use the top compressed blend shape, you'll see that it moves properly to the same place. If I move the bottom arm of the skeleton to 30 and then I use the blend shape for the bottom compression, you can see that it's working the same way. Let's have them at 0. Let's have the rotations here to 0. And this everything you need to do in Maya. You have your part rigged and you have your blend shapes saved here and controlled by this value from 0 to 1. Now just export this as an FBX file and we'll import it into Unreal, where we will continue with the process of setting distance that you want to be landing this particular landing gear. Let's continue in Unreal Engine. Import our part. It should contain the skeleton and the mesh that is skinned to this skeleton. And here into Unreal, check the skeleton mesh checkbox, import mesh checkbox. Make sure skeleton has nothing selected, because we are currently importing the skeleton. We don't want to use any existing skeleton in our scene. And into the advanced section, check import morph targets. It's really important in order to import the two morph targets for the top and the bottom part of the suspension. Click import. And this will import the skeleton mesh, the skeleton, and it will create a physics asset. Let's start with the skeleton mesh, and into the asset details, let's choose the proper materials from the KitBash 3D kit. Now it works as it was before we exported it. Let's click save, and we can delete all these additional materials here. Now we have a landing gear working, imported into the scene. And let's start creating the logic that will drive the top and the bottom suspension parts. The way I'll show how to do this will be with the animation blueprint. Let's create an animation blueprint and choose the skeleton asset that we created. So this will be landing gear tutorial skeleton, and hit create. Let's call it animation blueprint tutorial. Of course, choose a better name for yours, more descriptive for the actual function. And in this blueprint, we'll create the logic that will drive, based on the rotation of our bones, the movement of the top and the bottom suspension. Let's go into the skeleton mesh, and actually this is the skeleton mesh, and inside choose the post-process animation blueprint, and here you can select the blueprint that we created now. Let's click save, and this will ensure that this logic in our blueprint is applied to our skeleton mesh after any other animation. From the other animation we'll get a pulse, which we'll here use as an input pulse. And this input pulse will modify into our final output pulse that will control our suspension parts, the top and the bottom. Let's start with the top one. Create a bone driven controller. And for the source bone, let's start with the top bone. It will drive our morph target. The source component will be our rotation. Let's choose the rotation X for now, but probably we'll need to check it and make sure that we are using the proper axis. And now we need the name of the morph target that we will be driving. Let's open back our skeletal mesh. Inside you can see the two morph targets that we imported. For the top suspension we'll need this one, so copy the name and here paste the name of the morph target that you want to drive with the source top bone. We need to remap the values because the rotation will be from 0 to 30 degrees and the actual value for the morph target will be from 0 to 1. You can see that at 0 it's extended all the way and at 1 it's compressed all the way. That's why we need to remap the source value from 0 to 30 and will output from the range from 0 to 1. Let's compile and save. We need to connect the input pulse to the bone driven controller and then the bone driven controller to the output pulse. Compile and save again. Now when we move our top bone, it will control our top suspension. I have it connected to the wrong axis. It should be to the blue one. As you can see here from the colors, this is the Z axis. So let's choose rotation Z, compile and save. And now when we rotate from 0 to 30, it is properly increasing our top compressed morph target from 0 to 1. Let's do the same for the bottom one. Copy this, connect it to the other one, and now let's change the bone that we're using to control the movement to the bottom bone. Here the parameter name to the other morph target. And let's check now. The rotation will be again the Z axis. Rotation Z. It will be again from 0 to 30. Let's compile and save and test it. It's working fine. When it's at 0, we have it fully extended, and when we go to 30, it's fully compressed. It seems to work fine. And now what we'll do is we'll create one variable that will control the rotation of our bones, and then these bone rotations will control our morph targets with the setup that we already created. So let's make a transform modify bone component here. The bone to modify will be the top one. For the first one, we'll change the rotation. So in the rotation section, choose the rotation mode, add to existing. If we have any rotation, we'll add it to the current one, and then we'll split the pin for the rotation because we only want to rotate the Z value, and we'll promote this to a variable. Let's call it bone rotation, and we'll have the same one, copy and paste the same node, connect it to the other ones, and change to the bottom bone. Everything else will be the same. Connect our rotation to the rotation Z. And now, when we compile and save, if we change our value for this bone rotation to 30, actually we have it connected to the wrong values for the rotation. Let's change that. Now our bottom bone is fine, but our top bone is rotated the opposite direction. So we need to multiply this by -1. Now compile and save. Now it's working as we wanted. Let's say a value of 15 will be in the middle of the way from fully extended to fully closed 0. For every value we have our rotation of our top and bottom bones controlled by this single value, and our compression for the top and the bottom suspensions are driven by this rotation value as well. This everything for our animation blueprint, and it's already connected as a post-process animation blueprint to our landing gear. So it will work every time that we do an animation on our landing gear. It doesn't matter if it's imported animation or we control it with some other value. We'll have this blueprint adjust our morph targets accordingly. The next step is to start with the character blueprint. I assume that the viewer that requested this tutorial has some character setup. So I created this simple spaceship. It's just a box that will put the landing gears on. You can see here is the box collision component. Inside we have a spring arm and just this box mesh to represent the spaceship. You can swap it for any better mesh later. And we have a floating bone movement component in order to have the movement of our spaceship setup. Start with importing the landing gears here. Drag the skeleton mesh inside the viewport and move it in place. Copy and paste for the second one. And then copy and paste both of them and rotate. Now we have them all placed. Let's start with the blueprint code. Let's start creating the variables. So click the plus icon and start with the variable is landed. It will be a Boolean type. Then we'll need an array for our landing gears. Create one variable called landing gears. It will be of a type skeletal mesh component object reference, and the type will be array. The next variable will be landing distances. It will be of type float, and it will be array again. And the final one will be landing angle curve. It will be of a type curve float, and it will be a single type. For our landing distances array, we'll create 4 elements for the default value and put each at 30. because when we are landed, like you can see here in the viewport, all of our landing gears should rotate to 30 in our animation, because this was the angle that we must use to have the full animation for our landing gear. Let's populate the landing gear skeletal mesh component array as well. We'll do that in the construction script. So whatever you do for your character in the construction script, in the end, just control drag the landing gears array here, then use an add and start adding your landing gears to this array. We'll need 4 elements into the same array, and we'll put all the 4 landing gears here. Now we have an array with our landing gears and array with the landing distances, both with 4 elements. And our isLanded boolean should have a default value of true. Now let's go to the event graph and start set up the process for takeoff. So start with keyboard event. Let's say we'll do the pressing of the Z key. And what we want to do when we press the Z key is to start an animation that will start from 0, and then it will go to the landing distance for each of our landing gears. To start this animation, let's add a timeline. It will be takeoff animation. Double click to go in. We'll have the length of 2 seconds for this animation, and we'll add a float track. This float track we'll call animation multiplier or distance multiplier. We'll add a keyframe. The first one will be at 0, 0. We'll add another keyframe, and it will be on our max length. This will be 2, and the value will be 1. So we have 2 seconds animation that goes from 0 to 1. Compile and save, and go back to the event graph. For this animation, what we want to do is, for each landing gear, start the animation and animate to our landing distance in the array for the corresponding landing gear. Control drag the landing gears here and use a for each loop. That way we'll have the same code executed for the all 4 landing gears that we have in this array. For each of our landing gears, what we want to do is get the post-process instance. This is our post-process blueprint, and we want to set inside the bone rotation value. So first we need to cast it to the animation blueprint class that we made, animation blueprint tutorial. And then we want to set the bone rotation variable. And the value for the bone rotation will be calculated by multiplying this multiplier from our timeline with the value of our landing distance array for the respective landing gear index. So drag this landing distances array, get a reference, and the index will be the one that we are executing on our for loop. For each landing gear, get the proper distance and then multiply with this multiplier from our animation timeline here and set this to the bone rotation. That way, when we start the animation, we'll start from 0, and at the end we'll multiply 1 by 30. The end will be 30. So we'll animate from 0 to 30 our landing gears when we press the Z key. Let's test if it's working. Hit play, and now press the Z key. You'll see that each of our landing gears is animating from 0 to 30. If I press the Z key again, nothing happens. Play from start each time. That way, every time that we want to animate it again, the timeline will start again from 0. But we want to check if we have our spaceship landed, because now if I change that to play from start, and if I press Z, after the animation ends, if I press Z again, it will start from the beginning. I will add a branch node to check that if we are landed. Hold the B key, click anywhere, and this will create a branch node. And I will check if we are landed. This is the condition that we want to satisfy in order to play our animation. And when we finish our animation, we want to set our isLanded variable. So I'll drag it here into the event graph. And on the finished state of our animation, we'll set the isLanded variable to false. We can create the landing animation the same way that we have the one for the takeoff. I'll copy everything just to do it a little easier. So we'll make another keyboard event for the X key, let's say. So when we press the X key, we'll check if we are landed. For the landing animation, we don't want to be landed, so we'll disconnect the true value and we'll connect the false value. And because our timeline is set up to play from 0 to 1, for the landing we'll actually want to play reverse from the end. So it will start from 1 and will animate to 0. And after we're finished, we want to set our isLanded variable to true. Now if I compile and save, if I play, when I press the Z key, it will animate from the end and all my landing gears will compress. And if I press the X key, the animation will play in reverse and will land. If I play the takeoff animation and then move somewhere that I shouldn't be able to land, and I press the X key, our landing animation is played, and now we have the state set as if we have landed, and I cannot control my spaceship anymore. We need to fix that. Let's open again our event graph, and we want our landing animation to check if we can actually land. Are we close enough to the ground so we can land our spaceship? The way we check that is with a line trace. So after the check if we are landed, if we are not landed, so we are flying, we need another check. What we will do is do a line trace by channel. We'll create a branch node here, and we'll connect this return value here to the branch. So this return value will hit true if we successfully found a hit for our line trace between the 2 points that we set here. For the start and the end point, we'll check for each landing gear if we are close enough to the surface so we can land. Let's start with doing it just for one of them, just to explain how it works, and you then know how to do it for all of them just in a for loop. So I'll drag this one just to show you how it works, and we'll change it to the for loop later. So we'll get the world location for our landing gear, and this world location for each landing gear is the point that you have marked here with the movement controller. So it's on the bottom of each of the landing gears. It's your pivot point for the landing gear skeletal mesh. So this is the end position that we want to trace. So we'll start somewhere here at the top and we'll trace down to check if we have our ground underneath the spaceship. So in the event graph, this will be our end position, and we can subtract a little from our vector, so we can give a 5 centimeters gap below our landing gear. It will be easier to land our ship. And for the starting point, we'll add a vector. We'll have it start 2 meters away from the land point. And let's for now choose the draw debug type for duration, so we can see our line trace shown in the viewport. Hit the Z key to take off, and now when I hit the X key, I have a line trace for one of my landing gears with this red line, and it's hitting the ground. And because it's hitting the ground, we play all the animations. If I go higher and I press the X key, you can see that the line trace doesn't hit anything. It's just the line. It's not creating the dot for the hit. If I go down and I press X, a little bit more down. Now that we have this dot for the hit, the check for the successful hit is giving true, and that's why we are playing the animation. We want to do that for all 4 of our landing gears, and we want to play the animation for the landing just in the case that all 4 of our landing gears are in close enough distance to the ground so we can land. So control drag our landing gears array here again and do a for each loop. And for each of our landing gears, we'll get the world location. We'll do a line trace. If we have a successful line trace, what we'll do is we'll save the distance from our line trace into our landing distances array. So control drag our landing distances array, then hit an add. If we have successfully hit the ground with our line trace, let's split this pin and we'll save the hit distance into our landing gears array. Because the hit distance will be bigger than 30, and we want in our array to save values between 0 and 30. For now, let's do it that way. Delete this value by 200, because the distance from the start to the end of this line trace will be 200, because we are starting the line trace 200 units away from the place that our landing gear should land successfully. Let's save it like this into our landing distances array. And because we are adding here components, we need to first clear our array. So control drag the landing distances array here, hit clear. Now each time we try to land with the X key, if we are not landed, actually let's first check if we are landed and then clear the array. So if we are not landed, we clear our landing distances array, then we populate the array with the new hit values from our line trace. And then when we complete this check for all of our landing gears on the completed event of our for each loop, let's check if now our landing distances array has 4 elements. So get the length of this array, check if it's equal to 4. So we have a hit for all 4 landing gears connected here, and only if we have our 4 elements, then we can do the animation that we created earlier. And if we don't have our landing distances for all the 4 elements, then we'll not play this animation. We'll make a for loop. We'll do it 0 to 3. So it will execute 4 times from 0 to 3. And we'll add the landing distances of 30 for each of them, like we have our default values. Because we clear the array each time that we try to land our spaceship, if we don't successfully find 4 points for each landing gear, we want just to return back the default values. So we'll add an element of 30 4 times if we don't have successfully find the 4 line traces for each of our landing gears. We'll compile and save. And now if I hit the Z key to take off, if I hit the X key, we have landed, but we don't have our animation playing. Let's check. We have some kind of a problem with our landing distance, probably. We don't want to delete it by 200. We want also to multiply by 30. Because if I delete my landing distance of 200 by 200, it will return 1. And we need 30. This is just an example. I'll change that now to a curve. But I wanted to show you why we are doing this. Now if I hit Z, the animation will play for the takeoff, and if I hit X, you'll see that our 4 landing gears have this successful hit line trace for each of them. That's why we are landing. If I hit Z key to take off, and then if I move here and I go a little bit higher, if I hit the Z key, the X key, I have only one hit for the landing gear in the top, in the front left, and no hits for the others. That's why we are not playing the landing animation, and we are still flying with our spaceship. We can only land if our 4 landing gears are having successful hit point. So let's go a little bit lower and hit the X key, a little bit lower again, hit the X key. Because we have the 4 successful hits for our landing gears, we played our animation. But the animation is not taking into account what's the distance between our landing gear and the ground that we have. We always play the full animation. You can see that too if we play the takeoff animation. We just go lower and hit the landing animation button. Our landing gears are digging into the ground. To change that, we want to change our takeoff and landing animations to have calculation how far we need to go. Here we save our distance into the landing distances array, and the landing distances array should be used here properly to set our bone rotation, what we need to do subtract we'll subtract from 30 our landing distance value multiplied by our landing distance multiplier timeline, and then we'll add this value, and this is the value that we'll set for the bone rotation. We have some incorrect calculations here, so we need to subtract this value, and then we need to add the value multiplied by this animation. Now let's check. Take off with the Z key, move somewhere that we have different distances for all of our landing gears, then hit the X key, and you can see we have different animations for our landing gears, but it's not actually properly rotating them, and that's because we don't have linear difference for the Lengo that we want to use. Let's use the skeletal mesh, for example. When we have our rotation at 30-30, we have the minimum distance that we can extend our landing gear, and at 0-0 we have the maximum extended position for our landing gear. But in 15 we are not at the middle of this distance. The distance value is not directly changing with the same rate as the angles that we want to rotate our landing gears to, and that's why we created this curve variable earlier. Let's go back into our spaceship. We have this landing angle curve here. Right click into our content browser. In the miscellaneous section, choose a curve, and we want to create a curve float. Let's call it landing angle tutorial. I'll move it to the tutorial folder. And inside this curve, we want a mapping for our distance between 0 and 200 and what our angle should be depending on the distance that we have. I already have the curve created before here, so I'll show how it should look like. For the 0-0 value, we have a keyframe, and for the 200 value, we have a value of 30. And between them, we are not linearly changing, so it's not just a flat line. If we have our value at 100, it will not be 15. It will be somewhere around 7.5 degrees of rotation. Let me show you how to do that. Just add a key here, put it at 0-0, add another key, put it at 230, and now for both keyframes, choose the type as cubic interpolation and rotate them in the way that for the value of 100, so this line here is the 90, so the next one is 100, and the value should go a little bit under 7.5 degrees for the 100. Let's click save. Now let's go back to our spaceship. Now go here, instead of saving this value here that we calculate with these two nodes, I'll delete this. In this curve variable, we'll put the landing angle tutorial curve that we created now. We'll get the float value, and for the in time we'll use our hit distance. This will be a number between 0 and 200, and it will map the value to this other variable that we have set up from 0 to 30, and we'll set it in our landing distances array for each of the landing gears. Now if we take off with the Z key and we go a little bit lower and hit the X key to land, it's calculating properly the distance and the angle for each of the landing gears. I'll hit Z again, and for the takeoff animation we started from the beginning. We need to change that now. We only fixed the landing animation. Our takeoff animation here is not set up with our proper animation values, so we'll subtract our value from 30, and then we'll add this value to the one that we calculate from our animation. So subtract the landing distances value that we save, and then add it to the one that we are applying the animation. It's the same formula like we have for the landing. Here we have a mistake. It should not be multiplied. We should use an add node instead. Let's hit play. Press the Z key to take off. Now press the X key to land. Let's check from a lower distance. Press X to land. Press Z to take off. Now let's move somewhere that we have different values for each of the landing gears. Press X. Now press Z to take off. Now we have all our 4 landing gears animating properly, extending just the distance that they need, and animating for the landing and the takeoff animation with the proper distance setup. This is the setup that I have in the beginning of the tutorial. Hope that this helps the viewer that requested this tutorial, and it will help you to use any morph target animations in your characters. It doesn't really only need to be for this type of animations. Morph targets are often used for facial animations and for other organic characters. It's really beneficial to know how to use the morph targets animation, and this way with the post-process blueprint is the easiest way, I believe, that you can use to apply these animations to your blueprints. So that's everything for today. Please like and subscribe, and you can write for any requests for other tutorials, and I'll see you next time.